Doc's Blocks presents Braze Like a Pro. We offer a complete line of automotive AC products for building or repairing AC systems, unlike anyone else in the industry. We can supply everything from single components to complete assemblies. Most all automotive AC systems are now aluminum. Nearly all AC system lines have one or more brazed connections. In order to make cost-effective repairs on these systems, you need to be able to braze aluminum components. In this video, we will cover the most common brazing repairs, such as block to tube to tube, port to tube, nut union to tube to core repair, and hose repair. We talk to hundreds of both small and large companies every year. We have found three categories: companies that braze aluminum on a daily basis, companies that do occasionally, and then some that have not been successful. We've been brazing aluminum components for over 25 years. Our goal for this video is to give you the benefit of that experience in order to teach you how to successfully braze aluminum products and to show you how not to make the most common mistakes. Products we supply are as follows: Braze On Fitting Ends. These are available with male insert O-ring, male O-ring, and female O-ring fitting ends. These offer a quick solution for replacing O connections that may be stripped or galled versus replacing an entire hose or core. Anywhere you find an aluminum fitting, such as on suction lines, evaporators, condensers, corrosion caused by moisture permeation can cause the fitting to gall or strip when being removed. We also supply 3-foot tubes either with square cut ends or with end forms, which can be cut to length and brazed to the Braze On end fittings, allowing you to build your own lines. You can easily custom bend the tubes with a hand bender. Braze On Hose Ends. These are a quick connection, allowing you to replace the old hose ends with new. These can also be used with our tube and Braze On fittings, allowing you to repair and or build custom hose assemblies. Splices. These allow you to connect two tubes together. Our customers have saved hundreds of dollars by using these to repair leaking sections of hard lines used in rear air systems where tubes have been worn through due to bracket vibration or moisture permeation. Doc's Blocks. All new cars have a minimum of 6 block connections in the AC system. They are connected to ends of hoses, evaporators, condensers, hard lines, virtually anywhere there used to be a threaded fitting. Doc's Blocks offers the most complete line of AC block connections available anywhere. Best of all, we can sell you 1 or 1,000 pieces, depending on your requirements. Doc's Blocks Barbs. Commonly found in many shops, these are low-cost Braze On hose connections. Doc's Blocks Ports. Most ports are brazed directly to tubes. There are charge ports for connecting gauges for charging the system with refrigerant and ports that are threaded for connection to the thermocouples and pressure switches. Doc's Blocks Unions and Nuts. We supply a number of English and metric threaded unions that braze directly to the existing tube. Anywhere you find an aluminum fitting, such as on suction lines, evaporators, condensers, corrosion can cause a fitting to gall or strip when being removed. Doc's Blocks even offers an Orifice Tube Line Repair Kit. Braze a new Orifice tube line in place of old. Brazing. It's all about heat, filler metal, flux, and parts. Brazing heat sources: propane, Mapp gas, and acetylene. If available, propane is the best gas choice for brazing aluminum. Acetylene and Mapp gas are high-energy fuels. They generally create too much heat for aluminum and cause localized blistering or melting of the parent material. They can be used but are not as forgiving as propane. Filler Metal Alloys. There are numerous brazing alloys available for aluminum. Doc's Blocks brazing alloys have a liquid temperature of 800 or 1080 degrees Fahrenheit, making them ideal for aluminum automotive brazing applications. Whether using hand-fed wire or wire preform rings, Dox Block's brazing material containing an integral flux material is preferable for occasional use or low-volume manufacturing. The integral flux prevents shelf life from becoming a factor as it does in liquid fluxes, as well as automatically matching the amount of flux to the amount of filler metal. The joint quality is not influenced by having too much flux or not enough. Dox Block's tubes are informed using precision tooling and machinery, and our blocks or other end fittings are CNC machined, assuring original equipment quality and fit. A tight fit prevents the braze material from flowing into the joint, and a fit that's too loose won't conduct enough heat from the outside part to the inside. For an ideal braze joint, it is necessary for all the components to come up to brazing temperature at the same time. Remove oil, grease, and road film by brushing with a small stainless steel bristle brush, and then washing with a grease remover type cleaner, such as dishwashing liquid. Be sure to rinse thoroughly with clean water, and completely dry inside and out before preparing to braze. Fixture the components in a stable manner. The blast of hot gas from the torch will knock over weakly fixtured components. If the components aren't fixtured securely, it's easy to topple them over when applying filler metal rod instead of using preformed braze rings. Also, it's very important to have the least amount of contact possible between the braze components and the fixturing. Too much contact, like a bench vise or a large chunk of metal, will draw away the heat from the aluminum braze components and keep them from coming up to temperature. The components and braze material are clean, dry, assembled and fixtured properly. Now we're ready to braze. Dox Blocks now offers a torch developed specially for brazing aluminum products. In this video, you'll see how well this torch works as we make each repair. The torch is available with a hose that connects directly to a standard propane bottle. The torch flame should be a softer, gas-rich flame cone, and the flame should be directed at the area of greatest mass. Caution: when brazing a tube into a block, heat the block first and allow the conducted heat to heat up the tube. The tube has a lot less mass than the block, so it will overheat and melt very quickly under direct flame. Notice the block with the braze ring and the tube is merely resting on the open jaws of the vise. This minimizes contact and helps prevent heat from being conducted away from the block. The short tube is used only for demonstration purposes. If this was an actual repair, the tube would probably be on the end of a hose assembly, condenser, or evaporator. The heat from the torch is being applied directly to the block since it has the most mass. It is important to keep the torch moving to prevent blistering the surface of the block. Notice the tip of the blue flame cone is just touching the surface being heated. As heat continues to be applied to the block, the tube and the braze ring heat up also. As the components near the correct temperature, the surface of the braze ring will change appearance and become dull. At this point, the torch is moved upwards slightly. At that very instant, the braze ring will break down and the liquid flux will cause the molten filler metal to flow into the joint. Immediately withdraw the torch and allow the joint to cool until the filler metal turns to a dull gray. The part may now be quenched using a spray bottle filled with room temperature tap water, followed by submerging the block and the end of the tube in the water to cool the part completely. The remaining flux residue is not corrosive and need not be removed. However, for appearance, the residue may be brushed lightly with a small stainless steel bristle brush, using care not to damage the sealing surface of the block. Any remaining moisture should be dried using compressed air before reinstalling the part. In this scene, a charge port is being brazed to a hole drilled into a tube. straight flux core brazing rod is being hand-fed into the joint. Notice that the heat from the torch is being applied to the tube. This is due to the tube having the most mass in this instance. As the components near the proper temperature, the braze rod is applied to first one side of the port and then the other, leaving small deposits of braze material that will then melt and float to complete the braze joint. After the joint is cooled enough to allow the joint to solidify, the part is quenched with water. It is worth noting that a preformed braze ring would have worked for this application also. Here a machined hose barb is being brazed to a tube to simulate building a tube and hose assembly, repairing a damaged one. A preformed braze ring is used and heat is applied to the machined barb until both the barb and the tube are at the proper temperature. The torch flame is then quickly placed over the braze ring, completing the process. After the joint has cooled sufficiently to solidify the part is quenched with water. This scene depicts a tube with a hose crimp shell on one end, and the other end the tube is belled to allow insertion of a tube of the same diameter for an effective braze joint. This component can be used for building non-standard tube and hose assemblies, or it can be used to make repairs. Brazing is accomplished just as with the previous part. This scene shows a short tube with both ends belled, being used to simulate a repair splice joint. The best approach for using this type of tube is to braze each end of the repair tube independently. After completing brazing on the first end of the repair tube, turn the opposite end so that the bell end is facing up, and then braze it just as with the first. This scene shows an end-formed tube with a union, which is belled on the opposite end, allowing a tube of the same diameter to be slipped inside the bell for brazing. Since both parts are nearly equal in mass, the heat is applied to both parts almost equally. It is important that the open end of the bell is facing up to allow the brazed material to flow in, forming the best possible joint. Allow the part to cool until the joint solidifies and turns dull gray in appearance. In this scene, a tube is being brazed into an evaporator core using flux core rod. The heat is applied to both the tube and the inlet of the core until both have reached sufficient temperature, and then the rod is fed into the joint. It is necessary to feed rod into the joint, working around the tube until the joint is completed. After the braze is solidified, the joint is cooled with water from a spray bottle. This scene shows a small hole in the hairpin tube of an evaporator tube being filled with just the braze rod. The ease of making this type of repair is apparent. Hoses generally leak just beyond the ferrule. Properly fixture the hose and cut it. Fixture and cut the end tube just beyond the ferrule. Chamfer to smooth edges. Clean and place the braze ring on the tube with a new barb end. Braze the joint. And cool in water. Slide new ferrule over the new barb end and then slide into the ferrule. You are now ready to crimp the hose to the ferrule, completing your repair. Move the flame around the joint to keep the heat evenly distributed. The object is to bring all the components up to brazing temperature at the same time. Too much heat on one area will cause the surface of the aluminum to melt and blister before the inside of the joint comes up to temperature. With a softer gas-rich flame, the flame will start to glow as the materials approach brazing temperature. When using a Dox Blocks filler metal rod, now is the time to touch the filler rod to the joint. Keep moving the flame around as the orange glow gets brighter. This is the point where the flux begins to melt and lift the oxide layer away. As the filler metal begins to melt and flow, continue applying heat with the torch for a couple of seconds until sufficient filler material has been drawn into the joint. Remove the torch heat as soon as enough filler metal has been drawn into the joint for a full fillet. Do not touch any of the components or disturb the joint until the assembly is cooled down enough for the filler metal to change back from a liquid to a solid. Disturbing the joint too soon can cause microscopic cracks that will leak. When the filler metal has cooled back to a solid, quench the joint with water. Avoid the frozen turkey syndrome. Too much heat applied too fast caused the outside to melt before the inside became warm enough. Localized blistering or melting indicates keeping the torch focused on one area too long. Joint area was not hot enough to melt the filler material. The molten flux and filler will always migrate toward the hottest area they can reach. If the filler melts but flows away from the joint, it's another case of too much heat to the wrong place. Heat the part with the largest mass first and let the joint conduct heat evenly until it's hot enough to melt the filler alloy. For more information on Dox Blocks brazing, write us at Dox Blocks, 310 Pennington Drive, Paris, Arkansas 72855, or call toll-free 1-888-910-8844. You can also visit us on the web at www.doxblocks.com.